Now, picture this, October 27th, 2025. Moscow is still dark. Most people are asleep. Then, suddenly, the sky explodes in green light. A massive fireball tears across the darkness, glowing emerald, bright enough to light up entire neighborhoods. Dash cams capture it, security cameras record it. People rush to their windows. And within hours, the internet is asking the same question. What the hell was that? Here's where it gets weird. That same week, scientists are studying something else entirely, an ancient comet, one that's been traveling through space for potentially 14 billion years, longer than our entire solar system has existed. This comet is called 3I/Atlas, and is producing something that should not exist in nature, a metal compound that we've only ever seen inside aerospace manufacturing facilities. The timing? Almost too perfect to ignore. So what's really going on here? Is Moscow's green fireball connected to this bizarre interstellar visitor? And why is a Harvard astrophysicist saying there's a 30 to 40% chance this comet isn't entirely natural? I spent weeks going through the research, the scientific papers, the observations from multiple space agencies. And what I found is way more fascinating than any alien conspiracy theory. Because the truth about 3I Atlas is actually stranger than fiction. Let me start by telling you what happened in Moscow that morning. Because this isn't some grainy UFO footage. This is documented, verified, real. Early morning, October 27th. The sky over Moscow lights up green. Not blue, not white, green. That specific color tells us something important right away. When objects burn up in Earth's atmosphere, the color they produce depends on what they're made of. Green means nickel or magnesium. So whatever streaked across Moscow's sky that morning was loaded with one of those elements. Now, Russian scientists came out pretty quickly and said this was likely a meteor, just a space rock burning up as it hit our atmosphere. And honestly, that's probably exactly what it was. Meteors hit Earth all the time. Most burn up completely before reaching the ground. This wasn't like the Chelyabinsk meteor from 2013 that actually exploded and caused damage. This Moscow fireball was smaller, higher up, less dangerous. But here's what makes this interesting. That same week, astronomers around the world were intensely focused on 3I/Atlas, this massive interstellar comet that was making its closest approach to the Sun. And 3I Atlas? It's been producing massive amounts of nickel vapor, the same element that makes things glow green. Now, I want to be clear. These two events are almost certainly not directly connected. The Moscow fireball was a local meteor. 3I Atlas was millions of kilometers away at the time. But the timing got people thinking. And honestly, it's the perfect hook to talk about something way more mind-blowing. What 3I Atlas actually is, and why it's completely unlike anything we've ever encountered before. So let's talk about this comet, because calling it just a comet doesn't do it justice. 3I Atlas is a cosmic fossil, a time traveler, a messenger from a place and time we can barely comprehend. First, the basics. 3I Atlas was discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile. That 3I in the name? That stands for Third Interstellar Object. Before this, we'd only confirmed two visitors from beyond our solar system, Oumuamua in 2017 and Comet Borisov in 2019. Now we have a third. And this one is breaking every single rule we thought we knew about comets. Let's start with age. Scientists estimate 3I Atlas is somewhere between 7 and 14 billion years old. Think about that for a second. Our Sun is 4.5 billion years old. Our entire solar system formed 4.5 billion years ago. This comet could be 3 times older than that. It existed before our sun was even born. It was already ancient when Earth formed. When dinosaurs walked the planet, 3I Atlas was already billions of years old, drifting through the darkness of interstellar space. Where did it come from? Astronomers traced its trajectory backwards and found something shocking. This comet didn't come from another solar system in our neighborhood. It came from what's called the Milky Way's thick disk. That's a region of old stars that orbit above and below the main galactic plane. Stars that formed during what astronomers call cosmic noon, a period of intense star formation that happened 9 to 13 billion years ago. Chris Lintott, astronomer at Oxford, put it perfectly. This is an object from a part of the galaxy we've never seen up close before. We think there's a 2/3 chance this comet is older than the solar system and that it's been drifting through interstellar space ever since. But age isn't even the craziest part. Let's talk about size, because 3I Atlas is absolutely massive. And I mean massive in a way that shouldn't statistically make sense. Most estimates put the nucleus of this comet at over 5 kilometers across. That's more than 3 miles. For comparison, that's bigger than Manhattan from tip to tip. And the mass? Harvard astrophysicist Avi Loeb calculated it at more than 33 billion tons. Let me repeat that, 33 billion tons. This makes 3I Atlas somewhere between 1,000 and 100,000 times more massive than the previous interstellar objects we've detected. Oumuamua was tiny by comparison, maybe a few hundred meters across. Borisov was a bit bigger, but still nowhere near this scale. 3I Atlas is a giant, a monster, a cosmic heavyweight that dwarfs anything else we've seen come from interstellar space. And here's what's statistically bizarre about that. Based on how interstellar objects should be distributed by size, we should have discovered about 100,000 smaller objects before finding something this massive. Think of it like this. If interstellar visitors were people, we should have met 100,000 kids before ever meeting an adult. But instead, we spotted 2 kids and then immediately found a giant. That doesn't fit the pattern. It's like the universe is playing by different rules than we expected. So either we've been incredibly unlucky with our previous detections, only spotting the small stuff and missing all the big stuff, or there's something unusual about how these objects are distributed in interstellar space. Either way, 3I Atlas is an anomaly, and anomalies are where the most interesting science happens. Now, let's talk speed, because this comet is moving fast, really fast. 3I Atlas is traveling at 130,000 miles per hour. That's about 210,000 kilometers per hour. To put that in perspective, that's roughly 36 miles per second. In the time it takes you to read this sentence, 3I Atlas would have traveled hundreds of miles. This is the highest velocity ever recorded for a visitor to our solar system. And that speed tells us something. 3I Atlas has been accelerating for billions of years. Every time it passed near a star during its journey through the galaxy, gravity would give it a little push, a gravitational slingshot. Over billions of years and countless stellar encounters, those little pushes added up. Now it's screaming through our solar system faster than anything we've seen before. That kind of speed also means we won't have it around for long. 3I Atlas came, it passed close to the sun in late October 2025, and now it's leaving forever. We'll never see it again. It'll shoot back out into interstellar space and continue its billion-year journey through the galaxy. This is a once-in-human-history opportunity to study this thing, and scientists around the world are taking full advantage of it. Okay, here's where things start getting really strange. The chemistry of 3I Atlas. Because this is where scientists started scratching their heads and asking questions they weren't expecting to ask. In August 2025, astronomers pointed the Very Large Telescope in Chile at 3I Atlas. They wanted to analyze the light coming off the comet to figure out what it's made of. Different elements emit different wavelengths when they're heated, so by analyzing that light, you can figure out the chemical composition. It's like a cosmic fingerprint. What they found was nickel, lots of it. 3I Atlas was producing about 4 grams of nickel per second. That might not sound like much, but for a comet, that's significant. But here's the weird part. They found nickel, but no iron. None. Zero. Why is that strange? Because in nature, nickel and iron always appear together. Always. They're created together in supernova explosions. They're found together in meteorites. They're bonded together in planetary cores. Every single comet we've ever studied, including the previous interstellar visitor Borisov, showed nickel and iron together in similar amounts. It's a universal pattern. Until now. 3I Atlas breaks that rule. It's producing nickel without iron. That shouldn't happen. It's like finding someone with a left hand but no right hand. The elements are supposed to be paired. But wait, it gets weirder. The specific form of nickel being detected is nickel tetracarbonyl. This is a compound where nickel atoms bond with carbon monoxide molecules. And here's the kicker. This compound has only been observed in one place before: industrial manufacturing facilities, specifically aerospace manufacturing. It's used in a process for coating materials with pure nickel. Avi Loeb, the Harvard astrophysicist who's been closely studying this comet, said it plainly. There is only one place where that is known to exist, and that is in industrially produced nickel alloys. This was never observed for any other object. Now, before your mind jumps to aliens building comets in space factories, let's pump the brakes. This compound can form naturally under very specific conditions, extremely low temperatures, certain chemical environments. It's exotic, it's unusual, but it's not impossible. The problem is, we've never seen it happen naturally before in any astronomical object we've studied. 3I Atlas is the first. This is what makes the comet so fascinating. It's showing us chemistry that we didn't think happened in nature. It's expanding our understanding of what's possible in the universe. And it's forcing scientists to come up with new explanations for how this chemical process could occur without any industrial equipment involved. Let's keep going with the weirdness, because the nickel thing is just the start. In August 2025, the James Webb Space Telescope turned its powerful infrared arcs toward 3I Atlas. What it found was another record-breaking anomaly. The comet's coma, that's the cloud of gas surrounding the nucleus, is absolutely dominated by carbon dioxide. The ratio of carbon dioxide to water is 8:1. That's 16 times higher than typical solar system comets at similar distances from the sun. Most comets are water-rich, ice balls with some other stuff mixed in. But 3I Atlas? It's a carbon dioxide machine. This suggests the comet formed in a very different environment than comets in our solar system. Maybe a region with higher levels of cosmic radiation. Maybe a planetary system with a different chemical composition. Whatever star system this thing came from, it wasn't like ours. But the carbon dioxide dominance also creates another mystery. Despite all that CO2, 3I Atlas appeared to glow green in September 2025. Green comets usually get their color from diatomic carbon, C2 molecules. But when scientists looked for C2 in 3I Atlas, they found almost none. The comet has one of the lowest carbon chain ratios ever measured. So where's the green coming from? Some researchers think it might be cyanide. Yes, cyanide. 3I Atlas is producing massive amounts of hydrogen cyanide. In early September, it was pumping out about 800 sectillion cyanide molecules per second. By mid-September, that number jumped to over 4.5 quintillion molecules per second. Those are numbers so big they're almost meaningless to the human brain. But the point is, this thing is a cyanide factory. And cyanide can glow green under certain conditions. So maybe the green wasn't from carbon at all. Maybe it was from poison. Either way, it's another example of 3I Atlas refusing to follow the rules. Here's another thing that shouldn't happen: water production at impossible distances. In late August and September 2025, NASA's Swift Observatory detected something shocking. 3I Atlas was spraying water, a lot of water, about 40 kilograms per second. That's like a fire hose on full blast, just constantly shooting water vapor into space. Why is that shocking? Because 3I Atlas was doing this at a distance of nearly 3 astronomical units from the Sun. That's almost 3 times farther from the Sun than Earth is. At that distance, comets are supposed to be frozen solid, inactive, dead. The Sun isn't strong enough to heat them enough to produce water vapor. At least, that's what we thought. But 3I Atlas doesn't care what we thought. It was active anyway, spraying water like it was much closer to the Sun. Scientists are still trying to figure out how this is possible. Maybe the comet's interior is extremely volatile. Maybe it has internal heat sources we don't understand. Maybe the carbon dioxide sublimation is driving the water release even at low temperatures. Dennis Bodowitz, a physicist who worked on the observations, said, "When we detect water, or even its faint ultraviolet echo OH from an interstellar comet, we're reading a note from another planetary system. It tells us that the ingredients for life's chemistry are not unique to our own." That's a powerful statement. This ancient comet, billions of years old, from a part of the galaxy we've never touched, is carrying water. The same water that makes life possible on Earth. It's a reminder that the building blocks of life, the raw materials, are scattered all over the universe. And comets like 3I Atlas might be the delivery system, spreading those ingredients from star system to star system over billions of years. Let's talk polarization. This is getting a bit technical, but stick with me because it's important. When light bounces off an object, the way it scatters can tell us about the surface properties of that object. Scientists measure something called polarization, which is basically how the light waves are aligned after bouncing off the surface. Astronomers measured the polarization of light coming from 3I Atlas. What they found was extreme negative polarization. The measurement was negative 2.77% at a specific observation angle. That might sound like meaningless numbers, but here's the context. That's almost twice as extreme as any known comet, asteroid, or even the previous interstellar object Borisov. What does this mean? It tells us about the comet's surface. Extreme negative polarization suggests large particles made from a mix of icy and dark material. Think of it like a dirty snowball, but the dirt particles are big and the whole thing is very porous, like a sponge. The surface might be similar to certain objects in the outer solar system, like trans-Neptunian objects or centaurs, but again, more extreme. This finding led researchers to propose that 3I Atlas might represent a distinct new type of comet. It's not like solar system comets. It's not quite like the other interstellar comets. It's its own thing, a whole new category of object that we're only now discovering exists. The universe, it turns out, has more variety than we thought. And every time we study something from outside our solar system, we're forced to expand our definitions of what's normal. Now, here's something that really messed with astronomers' heads: the tail. Specifically, the direction of the tail. Comet tails are supposed to point away from the Sun. That's basic physics. Solar radiation pushes dust and gas away from the sun, creating the tail. It's like a windsock, always pointing downwind. Simple, predictable. Except 3I Atlas didn't follow that rule. In September 2025, high-resolution images showed that the comet had developed an anti-tail, a plume pointing toward the sun instead of away from it. That's not supposed to happen. It's like water flowing uphill. Scientists figured out what was going on. At about 3 to 4 astronomical units from the sun, carbon dioxide on the sunlit side of the comet was sublimating, turning directly from ice to gas. This released water ice grains that were heavy enough that solar radiation couldn't push them away immediately. Instead, they created this plume pointing sunward. It's a rare phenomenon, and it requires very specific conditions, but it can happen naturally. As the comet got closer to the sun, the anti-tail eventually disappeared and was replaced by a more traditional tail pointing away. The Nordic Optical Telescope captured images of this transition in September. It was like watching the comet correct itself, switching from weird mode back to normal mode. Some people saw the anti-tail and immediately thought artificial propulsion. If the tail can point toward the sun, maybe something's pushing the comet. Maybe it's not natural. Maybe it's maneuvering. But the physics checks out. It's explainable. Strange, yes. Unprecedented for an interstellar object, sure. But not impossible. Still, the anti-tail added to the growing list of unusual behaviors that made 3I Atlas stand out. This wasn't just another comet. It was a comet that seemed to enjoy breaking the rules. Let's talk rotation, or more accurately, the mystery of rotation. When astronomers observe asteroids and comets, one of the things they measure is the rotation period. How fast is it spinning? Most objects show clear brightness variations as they rotate. Different sides reflect light differently, so as the object spins, it gets brighter and dimmer in a predictable pattern. From that pattern, you can calculate how long it takes to complete one rotation. 3I Atlas doesn't do that. Its light curve, the graph of brightness over time, is remarkably flat. Variations of less than 0.2 magnitude over what's estimated to be a 29-hour period. That's unusual. For an object this size, you'd expect more variation. So what's going on? There are a few possibilities. Maybe 3I Atlas is nearly spherical. A perfect sphere doesn't change brightness as it rotates because every side looks the same. But making a 5-kilometer comet perfectly spherical is tough. Objects this big tend to be lumpy and irregular. Maybe it's rotating very slowly. If the rotation period is extremely long, we might not see much variation in the short observation windows we have. But a slow rotation is also unusual for objects that have been tumbling through space for billions of years. Or maybe the brightness is dominated by the coma, not the nucleus. If the gas and dust cloud around the comet is bright enough, it might wash out any variations from the solid nucleus underneath. That's possible, but it makes it hard to study the actual comet itself. NASA's TESS spacecraft actually observed 3I Atlas back in May and June 2025, 2 months before it was officially discovered. Those observations didn't reveal a clear rotation period either. There were hints of a 16-hour periodicity in some data, but nothing definitive. The rotation mystery remains unsolved. It's one more piece of the puzzle that doesn't quite fit, and it keeps astronomers guessing. Okay, let's talk about spacecraft. Because while 3I Atlas was passing through our solar system, we had multiple spacecraft in position to observe it, and some of them got incredibly close. On September 4, 2025, NASA's Psyche spacecraft, which is on its way to study a metal-rich asteroid in the main belt, passed within 0.302 astronomical units of 3I Atlas. That's about 45 million kilometers. Close enough to get some interesting data. Psyche's instruments were able to observe the comet and contribute to the growing dataset. Then, on October 3rd, 3I Atlas made a close approach to Mars. It passed within about 28 million kilometers of the red planet. That might sound far, but in space terms, it's pretty close. And we had spacecraft at Mars ready to watch. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both turned their cameras and spectrometers toward the comet. They photographed it, analyzed its spectrum, added more pieces to the puzzle. But here's the really cool part. In late October and early November 2025, scientists predicted that NASA's Europa Clipper spacecraft and ESA's Hera spacecraft might actually pass through 3I Atlas's ion tail. Not the dust tail, but the ion tail, which is made of charged particles stripped away by the solar wind. If those spacecraft did pass through the tail, their instruments would have detected those particles directly. In situ measurements. That's a rare opportunity. Usually we study comets from a distance. Getting to fly through one's tail and sample the material directly? That's gold for scientists. It's like instead of looking at a painting, you get to touch it and analyze the paint. These observations happened while 3I Atlas was behind the Sun from Earth's perspective, so we couldn't see it from the ground. But the spacecraft were in the right place at the right time. We're still waiting for some of that data to be fully analyzed and published, but it's going to tell us a lot about the comet's composition and behavior. Let's talk discovery, because there's an interesting backstory to how we even found 3I Atlas in the first place. The official discovery was July 1, 2025, by the Atlas telescope in Chile. But after the discovery, amateur astronomer Sam Dean went back through archival images and found pre-discovery observations going back to June 5th, almost a month earlier. Why didn't anyone spot it then? Because 3I Atlas was passing in front of the galactic center. That's the dense, bright core of the Milky Way, packed with millions of stars. The comet's faint glow was basically camouflaged. It was like trying to spot a firefly in front of a fireworks display. Possible, but really hard. The Vera C. Rubin Observatory, a powerful new telescope that's about to revolutionize astronomy, actually captured images of 3I Atlas during its science validation phase between June 21st and July 3rd, 2025. If Rubin had started full operations just 2 weeks earlier, it would have been the one to officially discover this interstellar visitor. This tells us something important. There are probably interstellar objects passing through our solar system all the time that we just don't see. Our detection systems are getting better, but we're still missing a lot. 3I Atlas is big and bright enough that we caught it. But how many smaller, dimmer visitors have slipped past us unnoticed? The answer is probably hundreds or even thousands. We're only just beginning to get good at these things, and as our telescopes improve, we're going to find more, a lot more. All right, now we need to address the elephant in the room, the controversy, the speculation, the question that a lot of people have been asking since 3I Atlas was discovered. Could this thing be artificial? Let me be very clear up front. The vast majority of scientists studying 3I Atlas believe it is a natural comet. Unusual? Yes. Unprecedented? Absolutely. But natural. The behaviors it exhibits can be explained by exotic but plausible physics. We don't need to invoke aliens or technology to explain what we're seeing. That said, one prominent scientist has been vocal about not ruling out other possibilities. Avi Loeb, the Harvard astrophysicist I mentioned earlier, has stated that he assigns a 30 to 40% likelihood that 3I Atlas does not have a fully natural origin. That's a big claim, and it's generated a lot of debate.
What's his reasoning? Loeb points to several factors: the industrial-like nickel emissions, the extreme mass, the anti-tail behavior, the flat trajectory through the ecliptic plane, only 4.886 degrees tilted, which would allow strategic access to planets in our solar system, the close approaches to Venus, Mars, and Jupiter, the fact that the comet went behind the Sun during its closest approach, potentially allowing for maneuvers we couldn't observe. Loeb has raised the possibility of what he calls a Trojan horse scenario, an artificial object disguised as a natural comet. He's even suggested that the eclipse of the comet by the Sun at perihelion could enable a clandestine reverse solar Oberth maneuver, an optimal high-thrust strategy for interstellar spacecraft to break and remain bound to the Sun. Now, here's the thing. Loeb is a serious scientist. He's not a conspiracy theorist. He's published hundreds of papers. He's chaired Harvard's astronomy department. His willingness to consider unconventional possibilities has made him controversial, but it's also pushed scientific conversation in interesting directions. The problem is, extraordinary claims require extraordinary evidence. And right now, there's no direct evidence that 3I Atlas is anything other than a comet. Everything we've observed can be explained, even if some of those explanations require us to expand our understanding of cometary chemistry. The nickel without iron? Exotic, but explainable by low-temperature chemical processes. The anti-tail? Rare, but physics checks out. The extreme CO2? Suggests formation in a different environment than our solar system. Unusual? Not impossible. Could 3I Atlas be artificial? In the sense that we can't prove a negative, sure, technically anything is possible. But is there evidence that it's artificial? No, not really. What we have is a collection of unusual natural phenomena that we're still learning to understand. And honestly, that's more exciting to me than any alien hypothesis. Because what 3I Atlas is teaching us is that the universe is far more chemically diverse, far more variable, far more surprising than we ever imagined. We thought we understood comets. 3I Atlas is showing us we don't. And that means there's still so much to discover. So where is 3I Atlas now? On October 30th, 2025, the comet reached perihelion, its closest approach to the Sun, at a distance of 1.4 astronomical units. That's actually farther out than Earth's orbit. It never got super close, but it was close enough that it temporarily disappeared from Earth-based observations because it was positioned behind the Sun from our perspective. The comet is expected to re-emerge and become visible again in early December 2025. Astronomers will be watching, collecting more data, trying to answer the remaining questions. But after that, 3I Atlas will continue on its way, accelerating as it swings around the Sun, building up speed, and then it'll shoot back out into interstellar space. It'll travel for millions of years before it even leaves the outer edges of the solar system, and then billions more years as it journeys through the galaxy. Maybe it'll pass close to another star system someday. Maybe beings in that system will observe it and wonder where it came from, just like we're doing now. We'll never see it again. This is our only chance, and the data we've collected will be studied for decades. Because 3I Atlas has given us a rare gift, a glimpse of chemistry from another place, another time, another part of the galaxy. Let's zoom out for a second and think about what this all means. 3I Atlas is a messenger,
Not in some mystical sense, but in a very real scientific sense. It's carrying information, chemical signatures from a star system that might not even exist anymore. The star that formed this comet could have died billions of years ago. That planetary system could be long gone, destroyed in a supernova, or dispersed by gravitational interactions. But the comet remains, a fossil, a time capsule. The water it's producing, the carbon dioxide, the cyanide, the nickel, all of these chemicals tell a story. They tell us about the conditions in that distant system, the temperature, the radiation levels, the composition of the protoplanetary disk from which this comet formed. We're reading a message written billions of years ago in a language of molecules and atoms. And that message is saying something profound. Life's ingredients are everywhere. Water, carbon compounds, organic molecules. These aren't unique to Earth. They're not even unique to our solar system. They're scattered throughout the galaxy, carried by objects like 3I Atlas, spread from system to system over cosmic timescales. This doesn't prove that life exists elsewhere, but it shows that the raw materials, the building blocks, are abundant. And if they're abundant, then the possibility of life forming in other places becomes much more likely. We're not special in terms of chemistry. The universe is full of the same stuff we're made of. There's something poetic about the timing of 3I Atlas's visit. We're living in an era where our technology is just good enough to detect and study these interstellar visitors. 100 years ago, we would have missed it entirely. 100 years from now, our telescopes will be so good that we'll probably detect dozens or hundreds of these objects. But right now, in this narrow window of history, we're catching the first few. 3I Atlas is only the third confirmed interstellar object ever. We are pioneers, explorers of a new frontier. And here's what's exciting. This is just the beginning. The Vera C. Rubin Observatory is about to come fully online. It will scan the entire sky every few nights, looking for anything that moves: asteroids, comets, interstellar visitors. It's estimated that once Rubin is operational, we'll discover an interstellar object every month or two, maybe more. We're about to go from knowing 3 to knowing hundreds. Each one will be unique. Each one will come from a different part of the galaxy, a different stellar environment, with different chemistry and different stories to tell. 3I Atlas has opened a door, and we're about to walk through it into a much bigger, much stranger universe than we ever knew existed. So, let's bring this back to where we started. Moscow's Breen fireball. Was it connected to 3I Atlas? Almost certainly not directly. But symbolically? Maybe. That fireball was a reminder that space is not empty. It's full of stuff: rocks, dust, ice, and occasionally ancient wanderers from distant corners of the galaxy. And sometimes that stuff intersects with Earth in spectacular, visible ways. The green glow from nickel, the same element 3I Atlas is producing, links them in a poetic sense. Two manifestations of the same cosmic chemistry. One, a small local meteor burning up in our atmosphere. The other, a massive, ancient comet passing through from another star system. Both glowing green. Both reminding us that we're part of something much larger. And that's the real story here. Not aliens, not conspiracy theories, but the sheer, overwhelming fact that the universe is far more diverse, far more active, far more interconnected than we ever imagined. Objects that formed in star systems that no longer exist are passing through our neighborhood. Chemicals that shouldn't exist in nature are showing up in comets. Water is being sprayed into space at distances where it should be frozen solid.
Every rule we thought we understood is being challenged. Every assumption is being tested. And that's exactly what good science is supposed to do. It's supposed to surprise us, challenge us, make us rethink what we know. 3i Atlas is doing that. It's a cosmic teacher, an ancient professor from the early galaxy, showing up to give us a crash course in humility and wonder. And we should be grateful for the lesson. If there's one thing you should take away from all of this, it's this: the universe is not done surprising us. We've barely scratched the surface. We've studied a handful of objects from beyond our solar system. We've detected a fraction of the chemistry that's out there. We're like explorers who've just stepped onto the shore of a vast, uncharted continent. And we're only now beginning to realize how much we don't know. 3i Atlas is weird. It's breaking records. It's doing things we didn't think were possible. And that's fantastic, because weird is where discovery happens. Weird is where science gets interesting. When everything fits our models perfectly, we're not learning anything new. But when something comes along that doesn't fit, that's when we have to dig deeper, think harder, expand our understanding. So whether you're fascinated by the green fireball over Moscow or the ancient comet producing industrial metals in the depths of space, the message is the same. Keep looking up. Keep asking questions. Because the universe is full of wonders we haven't even dreamed of yet. And every once in a while, one of those wonders swings by close enough for us to see, to study, to marvel at. 3i Atlas came from the cosmic dawn. It's seen things we can't imagine. It's traveled distances we can't comprehend. And for a brief moment, it's here, in our solar system, giving us a glimpse of the infinite diversity of the cosmos. That's not just science, that's magic. The real kind. The kind that makes you feel small and vast at the same time. And honestly, that's the best part of all of this. Not the data or the measurements or the chemical analysis, as important as those are, but the feeling, the sense of wonder, the reminder that we're part of something ancient and enormous and beautiful. Something that started billions of years before us and will continue billions of years after we're gone. We're just here for a moment, watching it all unfold, trying to understand even a tiny fraction of it. That's what 3i Atlas represents. A moment of connection between us and the deep past of the galaxy. A thread linking our small planet to the vast cosmic web. A reminder that we're not alone in the universe. Not because of aliens, but because we're all made of the same stardust, forged in the same ancient furnaces, scattered across the same immense expanse. So, the next time you see something streak across the sky, whether it's a meteor, a satellite, or who knows what, take a second to appreciate it. Because you're witnessing something that's been traveling for potentially billions of years just to cross your field of vision for a fraction of a second. That's rare, that's special, that's worth paying attention to. 3i Atlas is out there right now, leaving our solar system, heading back into the dark. We'll never see it again. But for a few months in 2025, we got to study it, to learn from it, to be amazed by it. And that's a gift, one that this ancient wanderer gave us freely, asking nothing in return. Just passing through, sharing its secrets, and then disappearing back into the endless night from which it came.
Now, I want to talk about something that doesn't get discussed enough when we talk about discoveries like this: the human element. The people who actually found this thing, who spent sleepless nights analyzing data, who argued about what the measurements meant, who rewrote their assumptions over and over again as new information came in.
Because here's the reality. Discovering 3i Atlas wasn't some Hollywood moment where someone looked through a telescope and shouted Eureka. It was messy. It was collaborative. It involved hundreds of scientists across dozens of countries, all sharing data, comparing notes, sometimes disagreeing, sometimes having to admit they were wrong. The Atlas survey in Chile that first spotted it, that's an automated system that takes thousands of images every night, looking for anything that moves. A computer algorithm flagged 3i Atlas as unusual. Then human astronomers had to verify it, calculate its orbit, realize that the orbit was hyperbolic, meaning it came from interstellar space. That realization probably happened at 3 a.m. in some observatory, with someone staring at orbital calculations and suddenly understanding what they were looking at. Then the word went out. Observatories around the world turned their telescopes toward this visitor. The Very Large Telescope in Chile, the James Webb Space Telescope, the Nordic Optical Telescope, NASA Swift Observatory, Hubble, TESS, Mars Express, ExoMars, Europa Clipper, Hera, an entire armada of humanity's most sophisticated instruments, all focused on one ancient comet. And each observation raised more questions. The nickel without iron? That required multiple confirmations because no one believed it at first. The extreme CO2 ratio? That took careful spectroscopic analysis and comparison with hundreds of other comets to confirm it was truly unusual. The anti-tail? That required high-resolution imaging and complex modeling to understand. This is how science actually works, not through lone geniuses having sudden insights, but through collective effort, through sharing, through skepticism and verification, through people dedicating their careers to understanding tiny pieces of the cosmic puzzle. And let's talk about what happens next, because the story of 3i Atlas isn't over, not by a long shot. Right now, as I'm recording this, scientists are still analyzing the data. Papers are being written, debates are happening, models are being refined. Some of the spacecraft observations haven't been fully processed yet. The potential ion tail measurements from Europa Clipper and Hera, that data is still being analyzed. If those spacecraft did pass through the tail and collected particles, the chemical analysis could take months or even years. But when it's published, it could answer some of the biggest questions we have about this comet's composition. There are also follow-up observations planned for when 3i Atlas reemerges from behind the Sun in December 2025. Astronomers want to see if its behavior has changed, if the water production is still going strong, if there are any new surprises as it heads back out into deep space. And beyond the immediate observations, there's the theoretical work. Scientists are building models to explain how nickel tetracarbonyl could form naturally in a comet. They're simulating the chemical conditions in ancient protoplanetary disks to understand how such an unusual composition could arise. They're calculating trajectories to figure out where in the galaxy this thing might have originated. This work will continue for years, maybe decades, because 3i Atlas has given us so much data that it'll take time to fully digest. Every unusual property needs explanation. Every anomaly needs investigation, and the answers we find will reshape our understanding of comets, of interstellar objects, of planetary formation throughout the galaxy. But here's something I think is really important to understand. The fact that 3i Atlas is so unusual, so unexpected, so different from what we thought we knew, that's not a problem for science. That's a feature. That's exactly what we want. Science doesn't advance by confirming what we already know. It advances by finding things that don't fit, by discovering exceptions to the rules, by being forced to expand our models and theories to accommodate new observations. 3i Atlas is doing exactly that. It's challenging us, pushing us, making us better scientists. And here's the beautiful part. We don't have to pretend we have all the answers. We can say we don't know yet, and that's okay.
We don't fully understand how the nickel tetracarbonyl is forming. We're not entirely sure why the water production is so strong at such a great distance. We can't completely explain the carbon dioxide dominance or the carbon chain depletion. And that's fine. That's honest. That's how knowledge grows. In 100 years, when we've studied hundreds or thousands of interstellar objects, maybe 3I Atlas won't seem so weird anymore. Maybe we'll have found dozens of comets with similar chemistry. Maybe the unusual will become routine. Or maybe 3I Atlas will remain unique, a genuine outlier that tells us about an unusual formation environment that no longer exists in the modern galaxy. Either way, we'll have learned something, and that's the point. There's also a bigger context here that's worth considering. 3I Atlas is teaching us about galactic ecology. Stay with me on this. When we think about ecosystems on Earth, we think about how different species interact, how nutrients cycle through the environment, how energy flows from one organism to another. The galaxy has an ecology too. It's just on a much, much larger scale. Stars form, live, and die. When they die, they spread heavy elements into space. Those elements get incorporated into new stars and planets. Comets and asteroids form in those systems. Some of those objects get ejected into interstellar space through gravitational interactions. They wander the galaxy, sometimes passing through other star systems. When they do, they potentially bring new chemistry, new materials, maybe even organic molecules that could seed life. 3I Atlas is part of that galactic ecology. It's a wanderer, a nomad, carrying materials from one system to potentially deposit them in another. And when you think about it that way, the fact that it's unusual makes sense. It came from somewhere else, a different environment, different conditions. Of course it's going to have different chemistry. This is how the galaxy mixes itself. This is how chemical diversity spreads. And over billions of years, this process has been happening constantly. Trillions upon trillions of objects have been ejected from their home systems and have wandered through interstellar space. Most never encounter another star, but some do. And when they do, they bring gifts, water, organic molecules, complex chemistry, the building blocks of worlds. Earth itself might have been seeded this way in its early history. Comets and asteroids from our own solar system certainly delivered water and organics. But maybe, just maybe, some of those impacts were from interstellar visitors. Ancient comets like 3I Atlas that happened to cross paths with our young planet billions of years ago. We'll probably never know for sure, but it's a humbling thought that the water in your body, the carbon in your cells, might have originally come from another star system entirely, delivered by cosmic wanderers over unimaginable stretches of time and space. Let me address one more thing before we wrap up: the alien question. Because I know some of you are still thinking about Avi Loeb's comments about the 30 to 40% chance that 3I Atlas isn't fully natural. Look, I get it. The idea of an alien probe disguised as a comet is exciting. It's the stuff of science fiction. And when you list all the unusual properties together, the industrial nickel, the anti-tail, the perfect positioning for planetary encounters, it can sound suspicious. But here's what you need to understand about probability assessments like that. Loeb is assigning those percentages based on how unusual the observations are compared to what we expect from natural objects. It's essentially a measure of surprise, not a measure of actual evidence for artificial origin. Think of it this way. If I told you I flipped a coin and got heads 10 times in a row, you'd be surprised. That's unusual. You might even suspect the coin is weighted or I'm lying. But 10 heads in a row can happen naturally. It's unlikely, but possible. And without additional evidence of tampering, the default assumption should be that it was just a lucky streak. 3I Atlas is like that 10 heads in a row result. It's surprising, it's unusual, it makes us raise our eyebrows. But unusual doesn't mean artificial. It just means we don't have a complete understanding yet. And frankly, invoking aliens every time we encounter something we don't understand isn't scientific. It's a cop-out. It's saying, I can't explain this naturally, so it must be artificial. But that's giving up too early. History is full of examples where we thought something was impossible or required exotic explanations, and then we figured out the natural mechanism.
Pulsars, when they were first discovered, were so regular that they were briefly nicknamed LGM signals for little green men. Scientists joked that they might be alien beacons. Turned out they were rapidly rotating neutron stars. Natural, explainable, just really cool. Fast radio bursts were a mystery for years. Some people speculated they might be alien communications. Turns out they're probably magnetars, neutron stars with incredibly strong magnetic fields. Natural, explainable, awesome. The point is, the universe is constantly showing us natural phenomenon that are weirder and more surprising than anything we could make up. We don't need to invoke aliens to make things interesting. Reality is already plenty interesting on its own. So while I respect Loeb for thinking outside the box and pushing the conversation, I'm firmly in the camp that says 3I Atlas is natural. Unusual? Yes. Unprecedented? Absolutely. But natural. A product of exotic but explainable chemistry and physics. And honestly, that's way cooler than if it were artificial. Because it means the universe is more chemically diverse, more variable, more surprising than we ever imagined. All right, we're coming up on the end here, and I want to leave you with a few final thoughts. Because 3I Atlas, the Moscow Fireball, all of this, it's really about something bigger. It's about our relationship with the cosmos, about how we fit into the universe, about what it means to be human in an age where we can study objects that are older than our sun. For most of human history, the sky was a mystery. The stars were lights on a dome. Comets were omens. Meteors were supernatural. We had stories and myths to explain what we saw, but no real understanding. That's changed. In just a few hundred years, we've gone from complete ignorance to sophisticated comprehension. We can now look at a green streak across the sky and say that's nickel burning up in the atmosphere. We can detect a faint dot moving against background stars and calculate that it came from another star system billions of years ago. That's astonishing. That's miraculous in its own right. The fact that a species of hairless apes on a small rocky planet figured out the fundamental laws of physics and chemistry and used them to decode the universe, that's arguably more impressive than anything aliens could have built. And we're still just getting started. We're still in the early stages of becoming a spacefaring civilization. We've barely left our planet. We've sent robots to a few nearby worlds. We've looked at distant galaxies through telescopes. But we haven't yet ventured out into the cosmos in any meaningful way. 3I Atlas reminds us of what's out there. The galaxy is ancient. It's enormous. It's full of things we haven't seen yet. And as our technology improves, as our knowledge grows, we'll encounter more and more of those things. Some will be familiar, some will be strange. Some will challenge everything we think we know. And that's exciting. That's what makes this worth doing. Not just for the knowledge itself, though that's valuable, but for the sense of wonder, for the feeling of being connected to something vast and ancient, for the realization that we're part of a story that started long before us and will continue long after we're gone. So, when you look up at the night sky tonight, or tomorrow night, or whenever you next get the chance, remember this. You're looking at a dynamic, active, living cosmos. Objects are moving. Stars are being born and dying. Planets are forming. Comets are wandering from system to system, carrying messages from the deep past. And occasionally, one of those wanderers passes close enough for us to see, to study, to learn from. 3i Atlas is one of those moments. A cosmic visitor that showed up, shared its secrets, and is now leaving. We were lucky enough to be alive at the right time, with the right technology to catch it. That's rare, that's special, and it's something you can tell people about. Hey, did you hear about that ancient comet from another star system? The one that's older than the sun? The one producing chemistry that shouldn't exist in nature? Yeah, that happened. In our lifetimes. We saw it. And there will be more. The universe isn't done with us yet. There are more discoveries coming, more surprises, more moments of wonder. We just have to keep looking, keep asking questions, keep pushing the boundaries of what we know. That's the real message of 3i Atlas. Not aliens, not conspiracy, but possibility. The possibility that the universe is far stranger and more beautiful than we ever imagined. And we're only just beginning to understand it. So stay curious, stay skeptical but open-minded. Question everything, but base your conclusions on evidence. And most importantly, keep looking up. Because the next cosmic visitor could arrive any day. And when it does, we'll be ready to meet it, to study it, and to add its story to the growing library of knowledge we're building about this incredible universe we call home. The cosmos is waiting, and it has so much more to show us. Subscribe to the Just About Earth.